What's up, guys? Welcome to back another video. Welcome back to another video. Today we're going to make a video about math. Yeah. So this question is interesting because it's simple actually. Okay. Honestly, it's not really that interesting. It's just I'm gonna make it interesting. Why? Because I'm gonna solve it in a more rigorous way. And that's because my other member, the one who does the other videos, forced me to it. So I'm gonna have to do it. But overall, this question is very simple. But yeah, I'm gonna show you the fun part. So firstly, let's see what the question is. The question states, for what values of a and b will f of x be differentiable? Now, as we see, it's a piecewise function, which is annoying, but it's not that hard. We have two functions, a quadratic and a linear function, and both of these are usually continuous across all x. Okay, but the problem here in this question, we don't know whether it's continuous at x equals 2. Because we have these. This doesn't tell us anything. Actually, it more shows that it might not be continuous. But for this question, we have to make it continuous. It needs to be continuous. So we're gonna prove that it is. To start off, to prove that this is continuous, we need to firstly plug in the 2 into the f of x, and we need to take the limit of f of x from the left and the right. Now, when we plug in the f of 2, okay, and we set it equal to the limit of x as x approaches, the limit of f of x as x approaches 2 from the left, from the right, and equal to the limit of f of x as x approaches 2 from the left. Now, f of 2, this part is tricky. Why? Because if you plug in f of 2, you'd think, maybe you could put it in this because it seems simpler and you'd get 2a. But that's wrong. Why? Because this function is not defined for x equals 2. So you can't really put it as, you can't really define it. But this question is defined for x equals 2 because, as you can see, it's x greater than or equal to 2. So for f of 2, we just plug in the 2 into this. And when we plug it into this quadratic function, we're going to get 4a minus 2b plus 3 equals, now this is the limit from the right of 2. Or sorry, the limit of as x approaches 2 from the right. And x approaches 2 from the right here. So we're gonna plug in 2 in this again. So that's gonna give us again 4a minus 2b plus 3 equals the limit of f of x as x approaches 2 from the left, and this is this one, ax, when x is less than 2. And so we plug in 2 into this again and we get 2a. Now, this and this are equal, which means that f of 2 is equal to the limit of f of x as x approaches 2 from the right. So we're gonna get that 4a minus 2b plus 3 is gonna equal 2a. This seems weird that we have something equals something which equals something, but this part is just to prove that the limit of f of x from the as x approaches 2 from the right is the same as f of 2. It's just like a way to describe it. So we're gonna end up with this, okay? And now we can solve to find an equation that tells us how far it is from being continuous, if I'm not wrong. Yeah, so when we solve, we're gonna get, we can minus 2 from both sides, which is gonna give us 2a minus 2b plus 3 equals 0. And then we can move the eraser and the 3 to the other side, which is gonna give us, actually I'm gonna erase this entire thing, which is gonna give us 2a minus 2b equals negative 3, and then we can divide 2 on both sides. Now just, this looks weird, I know, but you can technically split it into a 2a over 2 minus 2b over 2 equals negative 3 over 2, and these cancel out, which gives you, or gives us, a minus b equals negative 3. Now this just means that these would be continuous at 2 if this holds true. Okay, so now we need to find an a and a b that gives us this. Okay, so now we move on to the differentiability part, because, well, technically now we know that this is continuous if this holds. Now on to the differentiability part. To start off, again, we know that we need this and this equal when it comes to differentiating them. So they need to have the same tangent line or slope. Now to make that happen, we need the limit as x approaches 2 equal to the limit as x approaches 2 from the right and from the left. Okay, so now we just plug in. Let's take this part firstly, the right-handed side, and we know that here in the right-handed side we need to plug in the quadratic part of the function. So x squared minus bx plus 3. And same goes for f of 2. We plug in the same thing but evaluated at 2. Now this works this also comes out to taking the derivative at that point because it's equal. Okay, so we have that working for us. Also because this equals f of 2, so yeah, it's like taking the derivative of f of 2, which comes out to, or so you can use this expression, you can use the actual power rule and not have to use this thing. And now this part, the left-handed side, it could have been a bit more trickier, but luckily for us this question saves us, because when we plug in f of x, we're gonna be plugging in this, since this is the left side, we're gonna take a of x. But when it comes to this, we know that the limit of f of x from the left side as x approaches 2 is equal to f of 2, and that means that this limit and we know that this limit equals a of x, so f of 2 should also equals a of x, ax, sorry. So f of 2 equals ax evaluated at x equals 2. Now obviously these derivatives only work at that point, and only at that point. You can't just set them equal at any other point. It's just for 2, x equals 2. That's why it works. I was definitely not gonna get killed. Okay, so this means this is equal to this, which makes things so much easier for us, because now I can just delete all of this, and we can use the derivative rules. We firstly we set them equal to each other. So, well, we set the derivatives equal to each other. So the derivative of this is just 2ax minus b equal to the derivative of this, which is a. Now we evaluate, we plug in the 2, x equals 2. When we plug in that, we're gonna get 4a minus b equals a, and then we can just, how should I go about doing this? You can minus the a from both sides. You're gonna get 3a minus b equals 0. Then move the b to the other side. You're gonna get 3a equals b. So now we have this. And then this is where this part, the part from the continuity section, comes in. We plug in 3a to this b. So we get a minus 3a equals negative 3 over 2. Because of this, we're gonna get negative 2a equals negative 3 over 2. And then we just divide by negative 2 on both sides, which is gonna give us a equals 3 over 4. And since now we have the a, we can just go back into this thing we just found. Oh my god, this is one giant chunk of a question. And plug in a back into it. So 3 times 3 over 4 equals 3 times 3 is going to be 9 over 4. And that's b. So the values of a and b is a is going to equal 3 over 4 and b is going to equal 9 over 4. And that is the question. I hope you enjoyed this video. I hope you didn't get confused during it, and I'll see you in the next one.